In this lecture, we perform a psychrometric analysis of the AC system we began to design in lecture 11, that is the last lecture of chapter 1, namely basics of heat load. Recollect that we had estimated the grand total heat load to be 364,266 BTUs per hour. Also recollect the AC system schematic diagram shown on this slide. Recollect our requiring an ingress of 680 CFM of outside air or fresh air, and therefore correspondingly exhaust air from the room also being 680 CFM. Furthermore, the cooling coil's apparatus dew point and bypass factor were estimated at 54.67 degrees Fahrenheit and 0.1 respectively. The dehumidified air flow through the coil was estimated at 15989 CFM. The mixed air calculations are shown on this slide. Pause the video and go over the calculations carefully. On this slide, the return air RA, the outside air OA, and the mixed air MA are mapped on the psychrometric chart. Notice that MA is very close to RA. This is understandable since outside air is only 680 CFM while return air is 17085 CFM. Supply air calculations are shown on this slide. Again, pause the video and carefully go over the calculations. In this slide, we have mapped the off-coil condition OFC as well as the supply air condition, that is SA. Notice that 90% of mixed air gets cooled down to the ADP while 10% of it gets bypassed. The two get mixed and constitute the supply air SA. In this slide, we show how to calculate the heat removed by the cooling coil, knowing the unbypassed airflow through the coil and the on-coil and off-coil enthalpies of the air. In this slide, we show how to pick off the on-coil and off-coil enthalpies from the psychrometric chart and thereafter estimate the heat removed by the cooling coil. We are able to estimate the heat removed by the cooling coil to be 366,947 BTUs per hour. Remember that our estimate of the total heat load was 364,266 BTUs per hour. the two numbers seem to agree within calculation errors. This brings us to the end of chapter 2, Basics of Psychrometry. Thanks for watching.